going to work on the process of making our B encounter much more challenging, actually making it kind of fight back instead of just shooting some random lightning. We're going to start by allowing our B to move. We'll give him some destination positions and move him along there, and then talk about how we can use AI to make that even cooler. Let's dive in though with our B encounter. What we want is for the B object here, the B root, hit W and go into move mode, to move around during the fight, stop at different locations, and eventually let off that big laser blast that he's got. So we're going to start by creating some positions that he can move to. We'll predefine 4 or 5 of them, and then we'll dive into the B encounter script and see how we can hook those up and make him move among those points. We'll start by right-clicking on the B encounter, choosing create empty and making an empty object, and that's going to be way off at 0, 0, 0, like way over there. So I'm just going to zoom in where I want it, kind of loosely, and hit Control-Shift-F, and then zero out the Z position so that it's right there along the line. This looks pretty good. I think like somewhere right around here in the middle is good because it's going to do like a laser blast down there. So I'll take this point, and then I'll duplicate it. Actually, let's rename these real quick. Let's name this destination _1. I'm going to name it B destination _1. Delete that duplicate, and then I'll duplicate this one and get my second one with the underscore. I'm going to put this one kind of up and maybe a little bit closer to the top, and then I'll duplicate again, maybe do one that's down low here somewhere, and then one that's kind of I don't know, maybe in the middle, something like that. All right, I've got 4 destinations now, and I want to hook those up to my B encounter and have him move around those points. Let's go into our B encounter script, and first, the thing that I like to do is just give myself a reference to those points so that I've got something to use in my code. So we'll add a serialized field, and this is going to be a transform array because we have multiple transforms. It could also be a list of transforms. We'll just use a transform array, and we're going to call this B destinations. We'll go back into Unity and assign those real quick. First, I'll do a quick build, Control-Shift-B. Jump back into Unity, we'll assign those, and then we'll hook up the code for it. I know if I don't assign them now, there's a good chance that I'll forget to assign them later. That's why usually when I make a serialized field, if possible, I just go assign it. So it's locked. I've got the window locked on the B encounter. We'll drag the destinations onto the destination section, and we get all 4 of them. And then I'll unlock this so I don't get confused later. Go recheck my B encounter and open up the B encounter script. So in our on enable, we kick off a coroutine that starts the encounter. I want to change this up a little bit. Let's make multiple coroutines. Have our start encounter be something like a start lightning, and then have a start movement method that we call as well. So we're going to rename start encounter to start lightning. And then I'm going to duplicate line 33 and change lightning here to movement. We'll create a new coroutine with Alt-Enter, just generate a method. It's going to, of course, have string there, so I'll replace it with IEnumerator, and then we're going to add in our code. So first thing we want to do in this code is create a while loop. We want just a loop that's going to run indefinitely, just like we have here on line 50. We don't have any real setup to do, so we'll say while true, so for the rest of this thing, as long as this object's around, we want to get the next destination, figure out what that is, and then we want to move towards that destination. So say var destination equals _ B destinations at, and then let's create a variable for this, which would be our destination index. And then we'll generate a property or a field for this. I think I want to do this as a field so that I can see it in the inspector, just kind of debug it, although it could just be a local variable declared right here above line 39. I'm going to generate it as a field though. And then I'll just add the, well, let's make it, I'm going to make it a serialized field for now. I could make, no, I'm going to make it public because I don't want to accidentally get confused that it is a serialized field that I want to be serializing, but I do want to debug and view it and be able to change it and play around with it for a little while before I make it private. So I'll probably in the end make it private and have a show in inspector or something. But for now, I want to be able to also just slide this and adjust the value and try out different things. All right, so in our start movement method, we're getting our destination. Next, we need to get the direction to that destination. To do that, we say var direction equals, and here we just use our local position, transform.position minus the destination dot position. And this is actually wrong. This is broken, and it's a problem. And it's a problem that's very easy to fall into when you start moving around child objects. Let's think about this for just a second. The transform here is the B encounter transform. It is not the transform for our B's object, the B root here, this animator that we have. We need to use that object and move that around instead. So we need to move the underscore B transform, not the B encounter transform. To do that, we'll just change this code right here to say underscore B dot transform dot position. So now we've got the direction to the destination. Next, we need to normalize it, because when we subtract those two vectors, we don't actually get the direction. We get the entire distance in x, y coordinates, how far away it is, and in the direction. Essentially, we get the direction with the magnitude. We want the direction normalized, though, which is just setting it down so that the vector max, or the vector's magnitude, is 1. So if it's straight up and down, it'd be like a 1 on the y and a 0 on the x. And if it's at a 45-degree angle, it's whatever it is, like 7.707 on both of them, because I think it's 707. It normalizes them out so that the total magnitude, the total distance from the center, is still 1 unit. And that's what normalizing is. It makes it so that the distance from the center point in the direction is 1 unit, which in Unity is typically 1 meter. So we're normalizing our direction, and now we need to move in the direction of that normalized direction. So to do that, we're going to create another while loop. We'll say while vector2 dot distance, and here we want to check the B transform position and our own destination dot position. So while that is greater than, and here we want some sort of movement threshold. Let's just start with a 0.1, so a tenth of a meter. While it's more than a tenth of a meter away, missing a closing parentheses there. What we want to do is move towards that position. So we'll say underscore B dot transform dot position equals vector2 dot, see if I can get that right. Vector2 dot move towards, and we'll give it our current, actually, really, we don't even need the direction here. We'll give it our current position, b.transform.position, and our destination.position. Now that I'm realizing that we don't need that, we'll need the third parameter, though. So we'll need our speed, or our movement amount, which for now we'll start with time.delta time, which is going to move it 1 meter per second, because over a time of 1 second, it'll move 1 meter distance. That's what that third parameter is. Let's fix the formatting here and talk a little bit more about this code. So our distance check is up. I added an extra parenthesis. Our distance check is good, and now our B movement is, I think, solid. But again, we don't need the direction part now, because we're using the move towards method instead of actually adding direction. So I'm going to delete out lines 42 and 43. I did want to leave them in there, though, because that's kind of the default thing that I start to do when I start writing code. I end up writing things to get the direction, and then half the time realize, oh yeah, I don't need the direction. I'm using move towards. So we use move towards to move towards our destination, and there we go, clean up our formatting. And then finally, we want to yield return null. Once we've reached our destination, we just want to increment our destination index. So we'll say destination index ++, and then we need to check to make sure that our index didn't go past the number of B destinations that we have. If we got 4 B destinations, we get an index of 4, we're going to get an out of range exception. So we'll say if underscore destination index, did I get it right? There it is greater than or equal to our B destinations dot length, then we simply want to set the destination index back down to 0. So we're just going to loop it back down over to 0. So right now we're looping through all of these points, and our character, or our B, should move between them when the start movement method kicks off. Let's go into Unity now and see if it works. We should have our B destinations assigned. Just got to go double check that. Yep. And our B is in there, and our destination index right now is at 0. So we'll press play. And run on over here. Let the encounter start. He's going to go do that animation, playing back. And then he's going to go snap over, jump over to that first position. And then he's going to move to his second position, and his third position, and his fourth position. And then back down to the fifth position, or the first position, sorry. Get my words mixed up. Oh no, actually he's going to 3. Now he's going to the first one. And you can tell that by looking at the destination index. You can see he's going to 1. Now he's going to 2. And the reason I wanted to leave this open, if I just change this to a 0, then I can force it to go to the next one. I think I'll probably just make this read only though, so that it's just visible in the inspector, because I'm not seeing a lot of value in being able to change it. But I do see a lot of value in being able to debug it and see what it is. So now we've got our character moving around. We're going to go into plastic and commit that before we make the changes to make him choose something at random instead of picking the same point. And we're going to do that with a new class and something really cool and exciting, I think. So for now, let's say that the B moves between basic points, and we'll check that in.